Cool. All right. I'm Scott Braddock. I'm an assistant research professor here at UMaine, former grad student. I've been involved with JERP in a whole bunch of different capacities. I was a student in 2012, went back as field staff in 2015, and then have been teaching and doing research over the years since then. So I was pretty excited when Seth and others drummed up this concept of let's evolve the JERP undergrad program into a graduate program and kind of up the level of the research that we can do and actually provide a higher level of training for graduate students than they're going to receive in the undergrad program. So although there's a lot of overlap, there's some distinct differences between the two. JERP undergrad felt sometimes like part social experiment, part you're learning how to live with others in a foreign environment. And get like a tease and introduction into the research. The idea behind the grad program is to continue offering the safety component and how to live safely and survive in these environments, but then deep dive into the research. So over the past 2 or 3 summers, all these photos are involving graduate students, mostly from UMaine and Leeds, but as well as other universities that have been integrated into funded research. And that's going to continue this upcoming summer, but we're now expanding the students that we're involving in this funded research to anywhere in the US this first year. Yeah, so kind of repeating here, this course is designed for this training of scientists, again, to emphasize the safety of working in these environments and specializing in the field skills that you're going to need. So the first couple of days of the program in town, we have field safety staff teaching kind of rope work, knots, things like that. And then when they get on the ice the first few days, we'll continue that kind of implementing it when you're actually on a glacier. Then we can kind of all be on the same level of safety and then go out into the field day after day and start carrying out this research. Again, this is all funded research. So they're going to be collecting data that's going to be used in technical reports, publications. They'll be processing data in the field. So they're going to be actually a big contributor and part of the science. So as I go through this talk, if you have research on the ice field and whether you're doing it with JERP or independently, or you want to do more research on the ice field, think about how you can integrate a team of up to 15 grad students into your work and how that could help you reach different field sites, collect a lot more data. So we're hoping that you take away from this talk that there's an extra resource you can use here to integrate both your own students as well as others. And the idea is that we're going to prepare these graduate students to both participate in field programs, but also to lead, to gain that confidence and experience to lead polar field expeditions. I know as a grad student, all of a sudden you just defended your PhD and now you're expected to write a proposal, get funding, and lead your own trips, but maybe you've never done that. So we're hoping that this program can help students get a foot in that door and learn from a lot of people who have successfully worked in polar environments. So we're kind of selling this as covering broadly polar Earth system science. We don't want to target this and limit it to just people that are working with GPR or other geophysical instruments. We want to integrate engineers. We want people from biology, chemistry, physics. The idea is that we can start getting these interdisciplinary teams out there. We can get people who maybe are focused on modeling that want to get out in the field and then start seeing how the data collection works and if their model is showing what's happening in reality. So although it's being sold right now as this Earth systems broadly, I actually think we can do a better job of reaching a wider, broader audience next year. This again is the first year that we've started it within the mountain safety training. So this is kind of reading like a syllabus, but they'll gain 3 graduate level credits that's offered through UMaine. We were able to get an exception, so they're all going to pay in-state tuition, which saves a lot of money. It's a 4-week field season, a few days in Juneau to do the prep, and then flying up onto the ice. Unfortunately, this year, due to just the way the world is at the moment, we can only offer this to U.S. passport holders or students that are already international students here on a U.S. visa. We would love to open this up to international students once that becomes a much more clear pathway to how to do that. So stay tuned for that for next year, ideally. And I think we've maxed out in the participants this year at 15. possibly we're at 14, but I think we'll fill that last spot. So we'll have as many students as we can take on in this first year. That may or may not go up in subsequent years. That's something we're kind of feeling out this year. Is 15 a good number? Is it too many, too little? So this is the first year's JERP graduate program console. So these are also happen to be all the research faculty that are going to be up there. So Seth, of course, is part of the team. Kaya Riverman is kind of the bridge between the JERP undergraduate academic program and what we're trying to create here. Myself, Jill, I don't know if Jill's on Zoom today. She'll be presenting, but Jill coming from the University of Tennessee, Knoxville, working in the world of kind of microbiology. Curious if there's life under the ice. Pete, you all met today. Ryan Casado's not here, but you probably got a lot of emails from him leading up to this. Lynn Kaluzinski lives in Juneau, and she'll be joining us as well. She's a glaciologist. Dan, it's the only picture I found of you, so I didn't get you in mountaineering gear, but
He's always knows like that.
they have got
I was visiting the White House.
got a great cast here, and there's also the JERP team. Allie is working with us from JERP side to help with everything. So we envision that this console will change from year to year. It probably makes sense to integrate the faculty, the research faculty that will be working in the ice field, bring them into this. The role of this group is to kind of coordinate the science we're going to be doing, select the students that are going to be participating based on all the applicants, and kind of designing this as a 3-credit course. So as far as course deliverables go, there are 2 main components. There's of course the component of field work. So the students will kind of, based on their interests, will pair them up with a researcher or 2, and they'll tag along with them from day to day, learn how to use a certain instrument or answer a certain question out in the ice field. And we'll talk more about that. And then we also, as a takeaway from this, we want students to develop a series of these high school lessons that they can present locally, wherever they're coming from in a high school. So that could be something as in you go into the classroom yourself and you do a glacial flow model with a glacier goo, or maybe you just create some sort of online workshop that you can share with a teacher, and then you hand that out to the students. We're still going to figure out exactly what everyone's going to do. It's going to be based on their interest. Maybe they want to create a video and they can have students kind of tune in. I think we're going to have someone up there that's going to live stream some of the science this summer. He's really excited about it on Twitch of all things. So yeah, so that's another major component. We've had a lot of work with high school students over the last few years. Brad mentioned it since about 2022. Some of that funding has dried up due to the current administration, but if we can't get the high schoolers out to Alaska, we want our graduate students to then bring their experience to those students when they go back home. So that's a major component of this course. All right, just diving in a little more on each of these. So the active kind of research program that we're envisioning this summer is based on the expertise of the faculty as well as the funding sources that we have to get everyone out there. So we have all these different lines of research. We have snow and fern evolution. So this will be using GPR, ground penetrating radar. We'll have our LiDAR surveys. We'll have teams out there with doing snow pits and collecting samples for isotope chemistry. We'll be taking snow cores, fern cores. So quite a bit of hands-on experience. This is ongoing research being led mostly by Kaylee Manello here at UMaine and then others at UC Boulder. So we have a pretty well-established kind of field program for that, and students can slide into that really easily. We'll be collecting hands-on data and then going back to camp in the evening and processing it. So we have glaciology and glacier hydrology. This is going to be using, instead of shallow penetrating radar where we're looking at snow and fern, now we're trying to see, can we image what's going on in the subsurface of the glacier? Can we get the whole depth of the glacier? So using these deep penetrating radars. And then we'll have a hot water drill theoretically is going to be up there and operating, right? Yep. And that, I think we successfully got what, 300 meters or so?
273.
There, yeah, amazing. So we're going to punch some holes in the ice, both to make sure we can do it and the drill with the upgrades is working, and then what kind of science can we actually do with these boreholes that we have going down to bedrock theoretically. And that's still like if you have ideas for things you think would be interesting to measure, let us know. I think that is open-ended still about the possibilities. Polar geophysics. So we have other instrumentation just besides radar. We have seismic. We have some experimental radar systems that are being developed at the moment that we want to test up on the ice field. We have a distributed acoustic sensing. We have our UAV drone payloads, both the radar system and the LiDAR. So we have quite a bit of tools. That's just a few of the ones that we're going to be using up there. All those are going to be used to answer questions that we're asking in these larger funded grants. So we're not just going up there to play. Sometimes we are and experiment with things, but they're actually, the funded grants are driving the direction of this research that the students will be involved in. Microbiology, so I know there's a NASA team up there for the past few years interested in drilling beneath the ice, see if they can pull up samples that are clean and actually look for life, using this as an analog for missions going out to other moons or planets in the future. We'll have Jill joining us to continue some of that research up there. Landscape evolution, so not just snow and ice, but how is that shaping the landscape as snow and ice thaws and melts? How is that changing natural hazards in this landscape? Brad and others are going to be leading atmospheric sciences, so we'll have a bunch of mobile weather stations that we're going to be setting up across the ice field this summer, looking at kind of what are the microclimates across the ice field, and can we start mapping those and how they're changing it by elevation, by distance from the ocean to inland on the ice field. So a lot of cool questions we can answer there. And then finally, more polar sensors and R&D. So a lot of cool new toys that we'll have up there. All right, so that is a sample of some of the science that students get involved in. If you are doing science on the ice field that's funded already and you got instruments up there and you think you can integrate students, reach out to me, Seth, anyone on the council. And we'd love to figure out a way that we can get you up there during this program and work with graduate students. I probably didn't even mention this program runs June 1st, 30th this year, or June 2nd. So it'll be similar next year for the month of June. Touching on the outreach component, so these photographs are from outreach we did under NSF GeoPass grant that we had funded. So we actually brought students out to Juneau. They're digging into moraines, looking at the soil profiles. We have them actually going over some of the radar data we collected and talking about it in the classroom. And then we have outreach activities. This one we actually flew down to Miami, brought some of our research with us and interacted with middle school students down there. This is what we're envisioning, maybe not getting everyone into the field with high school students, but how can you use the science we're doing to create some fun interactive ways to introduce this future generation to polar sciences. So that's a key component as well. We have a lot of different funding to make this work, and Steph, let me know if I missed any. As far as the graduate student course, we were able to get funding this year to help reduce costs for participants. I'll talk about that as one of the challenges. Patel, I think you Maine, is there any other that I missed?
Maine Space Grant.
Maine Space Grant, another one from NASA. And then our funded research this year is a combination between NASA, NSF, and then we have this cold regions research and engineering lab for Corel. And are there any others I missed there?
Those are the three.
Those are the three this year. So yeah, we have people with funding from a bunch of different government agencies this year. If you want to get involved, the idea is that this is going to be an annual program. This is the first year to see how it runs, and then a big component of this is still going to be funding in future years. So for graduate students themselves, if you have students or you are a student, so we're only taking students that are enrolled in a graduate program or about to start one. So let's say we have a few students that are joining us this summer that'll start in the fall of 2026. So they're not technically not grad students yet, but they've accepted a program. And currently, only U.S. passport holders or international students with a U.S. student visa can participate right now. And that's out of our hands. That's with the challenges of bringing international students in. Visas right now, it's very uncertain and changing day to day. If you're a research faculty, so we don't necessarily have the funds to support you to come up and do research, but if you have a grant that's already funded or want to join us on a future grant with an idea or to put in a proposal, that would be amazing. If you can get yourself up to the ice field with your equipment and you have some science to answer, we can help integrate a team of students into that research and kind of work collaboratively on that. Some of the challenges, the next steps. So just being very upfront, this year we've got the cost down to 4,800. I say down to, that's still pretty expensive. So that is field fees, tuition for the 3 credits, but doesn't include travel and some of the gear they might need. I think fortunately a lot of these students, their programs are helping support them to come out here. It's my understanding, which makes a big difference, but we want that number to go down, but that's a major challenge. We'd also love to reach more students, so whether that's international community or some of these first generation college students that come from low income families. Those are a lot of the upward bound students that we've worked with on our previous outreach high school programs. We want to try to create this, not just outreach and talk to them as high schoolers, but provide them a pathway into this field and an introduction. So the undergrad program would be the first step for that. But if they continue on, integrating them into the graduate program as well. So securing funding is going to be a challenge. Not only do we secure funding to lower the participant cost, but we also have to support safety staff, a camp manager, an in-town logistics person, a mechanic. So it's expensive. There's a large team that makes this run smoothly and a lot of volunteer hours of people doing this because they love it and they want to, which is a huge part of our team this year. And then we want to engage the wider cryosphere. So bring in people from this community that maybe aren't part of the people that have been working in the ice field for 20 years straight at this point. Start bringing in some new ideas, some new science questions that we're trying to answer and integrate them into our program. So that's pretty good timing. I'll leave it there, but I think we can open this up to questions now related to the JERP graduate program or anything that was mentioned by Brad, Seth, and Corey. And there's all the information is up on the website for the JERP grad course. That's linked there. So yeah, any questions or comments, thoughts? Same from Zoom, open up to you all.
I'll ask a question, and sorry if I missed this, my Zoom dropped for a second. But the physical location of this, what camps are you going to be operating out of with the grad
Yeah,
program?
I should have mentioned that. So we'll be operating out of Camp 10 in the heart of the ice field, but with that access to snowmobiles that Andy mentioned that we were able to purchase on grants, we can pretty much get over the whole southern half of the ice field. So we'll take trips over to Camp 18 up to the Divide, for example, and then some of the other branches that go off to Taku. So we have a wide range where we can reach, but the graduate students and research faculty will fly into Camp 10 as their base camp this first year.
Yeah. And Billy, can you hear me? This is Seth.
Yeah.
Well, hey, yeah, glad you're here. You know this, but from Camp 10, we can get over towards at least like Echo looking down on Gilkey and get down towards that area. And we do have plans this year to kind of do work in Gilkey, looking down in Gilkey, Trench, but also in Avalanche Canyon. And we've certainly started talking about how we might team up with you guys at Gilkey Terminus to gather some observations that are coincident with information we want, but also valuable for you guys.
Cool. That sounds awesome.
Yeah, and this first year, like Camp 10 is where we're based out of because we can answer a lot of the research questions we're trying to do, but there's no reason that we couldn't work on the margins of the ice field or other places we don't normally access if there was a question there and grant funded to work there. So we don't want to limit the scope of where it can work, but yeah, Camp 10 is kind of the base camp this year. Any other questions?
Are you getting mostly master's students?
That's a good question.
Master's students, I think, but we can have a few PhD.
Yeah, we definitely have a few PhD students, but I think a lot of masters. And it's interesting, like the experience this first year is going to be first year master students, some of them coming without any background in polar sciences versus some upper level PhD students. So we're gonna have a lot of mentoring with peers to help each other as well as the faculty. So it'll be a challenge to figure out what level we should be introducing concepts and integrating students. I know a few of the applicants are engineers or they come from, I think, like a policy background even, which is great. We want that, but yeah, it's a big mix.